Our objective for today, I can solve and graph multi-step one variable equations involving absolute values. Let's read together. 1, 2, 3. I can solve and graph multi-step one variable equations involving. So we're still on multi-step one variable equations, right? The only thing today we're going to look at a different view in regards to absolute values. Okay? So, do we need to write Fermat for one variable equations? No, we already know what they are. We covered that already. We already know our steps. Tell your neighbor the steps for solving equations. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Okay, so we got that, right? Thank you. So we already know those steps. We're going to continue a little bit more today, okay? All right, here we go. Next, let me introduce absolute value real quick. Focus, please. Pens down. You need to write this. Just pay attention. So what is absolute value? I kind of introduced this at the beginning of the year, just in case you forgot. Absolute value is the distance of a number away from zero. 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 If you didn't understand what it is. Yeah. What is it? The distance of a number away from zero. So yes, the distance of a number away from zero. And the reason I want to make sure I get this down so that you understand what we're looking at. What are we looking at? The distance of a number away from zero. We got it? All right. So the distance of a number away from zero is the absolute value. What is it? The distance of a number away from zero. We got it? You got it by now? All right, just double check. Now check this out really quick. Notice that the red letters say distance away from zero. That's why we use these bars right here. Now let me illustrate again. I did this at the beginning of the year. Here it goes again. If I was to give you a number line and I said, what is the distance from 0 to negative 23, you would say 23 steps. Is that correct? However, what if I said, what is the distance of 0 to 23? 23 steps. Is that correct? All right. That's why they use those symbols for absolute value, because it indicates the distance of a number to 0. Everybody with me? Now check this out. Let me illustrate. Here it goes. So let's say they say, what is the distance of negative 25 away from 0? Let's find out. 1, 2, 3, 4, 5, 6, 7. How many steps? 25 steps. It's kind of like if I said, let's see, Kyle, go outside the door, and I want you to go to the front office and count the steps as you go to the office to get me passes. And he's going to, okay, 1, 2, 3, all 467 of them. So you get there. And then on your way back, I want you to count them again to see if it's correct. Are you going to come back and count negative 1, negative 2? No, right? You're still going to count what? Positive steps. Same thing on the number line. Doesn't matter which direction you go, the steps are always counted as positive. So remember last year your teacher told you, absolute values are always positive. Remember that? That's why, because it's the distance. Distances are counted as positives. Okay? All right. Now check this out. Another way of saying this, check this out. We know that the distance from 0 is called what? Absolute value. Here's another way of saying it. What is the absolute value of negative 25? Why? Because absolute value means what? The distance from 0. What's another way of writing this? Do we know what the symbols are for absolute value? Yes, the 2 bars. So check this out. Absolute value negative 25 is what? 25. Are we there? So far so good? All right. So let me give you one more illustration. This is how it's going to get started in regards to what we're going to be looking at today. And let's say they ask a question. What number is 23 steps away from 0? Let me show you with a number line so you guys can picture it. Here you go. Here's the symbol. What number, since we don't know what number, we put x, is 23 steps away from 0. Here we go. Here's the number line. Look at it. So what number is 23 steps away from 0? 23. Is that the only number, 23 steps away from 0? No. Also, the negative 23 is 23 steps away from 0. So check this out. So how else can we write this? So if you were to get this equation, check this out. If they were to say, what is the what number is 23 steps away from 0? We write it like this. Check this out. 1 has to be a negative, is that correct? Negative 23. What's inside the absolute value? X. And the other one has to be a positive. So this is 23. And what's inside the absolute value? X. So therefore, what numbers should X be? Negative 23 or 23. So my solution set is negative 23 and 23. So far, so good? Kind of, sort of? Okay, don't copy that. Copy this next one down, though. Example number 1. Here it goes. Copy this one. It says, example 1a, solve the equation. Absolute value of x equals 12. Absolute value of x equals 12. Copy that. Okay, here we go. Everybody look up. Focus, focus. Check this out. Guys, eyes up here. So, by looking at it, it's asking, what number is 12 steps away from 0? What would you say? 12 and negative 12. So, therefore, we write whatever's inside the absolute value. So, x equals negative 12 and x equals 12. Remember, we got to make one that's negative and one that is positive. So far, so good? Okay, let me give you another one. Write this down. Example 1Q. What number is 7 steps away from 0? Here we go. Who got negative 7 and 7? So therefore you write x equals negative 7, x equals 7. So for this one, the solution set was negative 12 and 12. And this one was what? Negative 7 and 7. So far, so good? Yes. This, for right now, I want you to follow the entire process, and I'll show you why. Because right now, when we get into multi-steps, this is only a simple introduction. But when we get to the multi-steps, I want you to write it out so you guys can see it. Okay, so check this out. Let's go to this next one. Here we go. Copy this one down, please. Example 1B. 1B. It says, solve the equation. Absolute value of x minus 3 equals 23. Michael Jordan. Eyes up here. Okay, focus. You're saying, wait a minute, this is a little bit different. It's a little bit different, right? Who notices that this one has a minus 3 next to the absolute value? So to leave the absolute value by itself, we need to add 3 to each side. Add 3 to each side. We're left with absolute value of x equals 26. Do we know what to do with this? Yes. 1 negative 26, so x equals negative 26. And 1 positive 26, so x equals 26. So therefore the solution set is negative 26 and 26. Copy that, please. That was example 1B. Copy example 1C down, please. Example 1C, solve the equation. 8 equals absolute value x minus 2.5. Close the absolute value. All right, here we go. Pens down, eyes up here. Focus. Okay, compared to the other ones we just did, notice that this one now inside of the absolute value has something else. However, outside of the absolute value, is there anything that we can get out of the way, on the right side or the left of the absolute value? No. The absolute value is already by itself. You guys notice that? If you don't see it, let me draw my line down the equal sign. Look at this side. Is there anything on this side or this side? No. So therefore, at this point, what would we do if it was the other kind of equation? Let's see. Let me go back to the other one. Once we have it like this, what do? We write this one negative, one positive, and we rewrite whatever's inside of the absolute value for each. Does everybody see that? Yeah. So therefore, look at this one. This one becomes a what? Negative 8. And what's inside the absolute value? X minus 2.5. So we did one negative. So what do we do over here? One positive. So this is positive 8. What's inside the absolute value? X minus 2.5. However, are these already solved for X? Let's see. Is it X equal to something? No. What do we need to do? Add 2.5. Add 2.5. So therefore, this is negative 5.5 equals X. And this one, add 2.5, add 2.5. 10.5 equals X. So therefore, my solution set is negative 5.5, comma, 10.5. Copy that, please. Please, this was example 1C. Copy example 1D. All right, copy this next one, example 1D. Solve the equation 3 times the absolute value of x plus 7 equals 24. 3 times the absolute value of x plus 7 equals 24. Let's do this one together. Check this out. Line down my equal sign, and let's see. Let's look at this side. Look at the absolute value. Is there anything outside the absolute value? What is it? 3. And what is the 3 doing? Multiplying. So to cancel it, or to get rid of it, we need to divide by 3. Whatever we do to one side, we do to the other. 3 divided by 3 is 1. We're left with absolute value x plus 7 equals 8. Since we're already done with nothing outside of the absolute value, here we do 2 equations. One negative, so this becomes negative 8. Is that correct? What's inside the absolute value? X plus 7, and one positive 8. And once again, what's inside the absolute value? X plus 7. And how do we solve this? Minus 7 minus 7, x equals negative 15. This one minus 7 minus 7, x equals 1. So my solution set is negative 15, comma 1. The parts are good? Okay, let's move on. Example 2A. 2A. Copy this next one down. Copy that one, please. Example 2A. It's negative 8 equals absolute value x plus 2 minus 8. Okay, let's do this one together. Here we go. Line down my equal sign. All right, let's look at the side that has the absolute value, which is this one. Is there anything outside the absolute value? Yes. Yes, a minus 8. So how do we cancel that? Add 8. Add 8. Isn't it subtract 8? So what is the opposite? Add 8. These cancel. We're left with 0 equals absolute value x plus 2. So now think about it. At this point, we would write 2 equations, don't we? Bless you. One negative and one positive. However, pay attention, please. Can we write negative 0 and positive 0? No. There's no maybes. Is there a positive 0 or a negative 0? No. So therefore, at this point, we don't do this. We just write the 0 and write whatever's inside the absolute value, x plus 2, and we solve. Minus 2 minus 2, negative 2 equals x. And we're done. You're saying, wait a minute. Aren't we supposed to get two different answers? Yes, but all the other ones. However, this one had a what? 0. And what do you notice? That only gives us one answer. So far, so good? Okay, let's move on. Copy this next one down, please. Example 2B. Example 2B. Solve the equation 3 plus absolute value x plus 4 equals 0. Copy that. All right, here we go. Everybody look up. Let's do this one together. Line down the equal sign and look at this side. We have a, guys, focus. We got to finish. We have a positive 3 here. How do we cancel this positive 3? Subtract 3, subtract 3. We're left with absolute value x plus 4 equals to negative 3. And check this out. At this point, this would be no solution. Think about it. Don't say it out loud. And let me go back so you can see the other examples and you can notice the difference. Here it goes. It goes from the beginning. Look at all these. Oh, sorry, not that one. Look at this one. This one had positive 23 and we came up with 2 answers. This was positive 12, we came up with 2 answers. This was positive 26, we came up with 2 answers. This was positive 8, we came up with 2 answers. This was positive 8, 2 answers. This was a 0, 1 answer. And this is no solution. Look at it. Tell your neighbor why.
I don't have a clue.
Who saw? Because it had the negative. That is correct. There is no such thing as negative absolute value. Remember, we count steps in positive. We don't count steps in negative. Absolute value is distance. Okay? So write a note for yourself. Note. No solution, comma, because there are no negative distances. 10Q. Okay, let me show you where we're at so far. Copy this diagram really quick. Okay, here we go. Absolute value. This is where we're at. For absolute value, we found out so far that there are 2 solutions. There have been 1 solution, and there have been no solution. So here we go. How do we know? We know that there are 2 solutions. If we have simplified the absolute value, we leave the absolute value by itself, and that's equal to a positive number. Right? Doesn't matter what's inside in here, x plus 3, x minus 2, whatever it is. And if it's equal to a positive, then we have 2 solutions. However, if we have an absolute value and that's equal to 0, how many solutions? 1. And then the last one that we saw, the absolute value equal to a negative number, there is no solution because there are no negative distances. Okay? Everybody copy this already? Okay, good, because I'm about to explain a word problem. Here we go. Okay, here goes the last example. Example 3A. You don't have to copy this, just pay attention. Everybody look up, please. It says, Sydney Harbor Bridge is 134 meters tall. The height of the bridge can rise or fall 180 millimeters because of changes in temperature. Well, this is, because this is made out of metal. What do we know about metal? That with the heat, it becomes what? Flexible, right? But with the cold, it compresses. It compresses, it becomes smaller. So therefore, if you were to get something that's flat like this, everybody look up, like this bridge that's flat. In the summer, because of the heat, number one, and because of the weight, this is going to go down a little bit, right? And in the winter, because of the cold weather, it's going to go up. So therefore, this is going to rise or fall. It's going to go up or down by 180 millimeters. But the height of that bridge is 134. So they want us to write an absolute value equation. Check this out. Absolute value of x minus, what was the height? 134. And what is the difference that's going to change positive and negative? That goes up positive or goes down negative? What was the distance? 180 millimeters. But didn't we write 134 and it was meters? So therefore that means we need to convert this one to meters. How many millimeters in a meter? Mil means 1,000. So if we were to divide 180 by 1,000, this becomes 0.18. How do we do that? 180 divided by 1,000, that's that. And do we know how to solve these? Yes, we become one positive, one negative, and we solve the equation. Okay? Homework. Homework is found on page what? 117. Numbers 1 to 33 odds. Keep the homework from the weekend. I'll pick it up tomorrow. Work on this homework tonight. Have a good one, guys. Enjoy your homework. See you guys tomorrow.